Okay, it's going live stream. Just 2 seconds. Hi everyone, so here we are presenting Women Who Code Daily Chapter next online meetup, which is going to take place by Ekta, and she's going to talk about testing in Golang. And Ekta is a software engineer at Grofers, and she has rich experience in giving talks and, of course, in Golang. And she's also been an international speaker. So, welcome Ekta to the group, and we are, like highly delighted that you are part of the Women Who Go as well, and taking the time to give the talk on this topic. Thank you and welcome.
Hi, Rashmi. Thank you. Thank you for the introduction. So I'll be talking about testing, basic testing in Golang, how we can use the basic framework of Golang, which is a part of the default packages which comes with Golang. So yeah, let's start. So Rashmi, is my screen visible? Should I start?
Yes, of course.
Okay, cool. Yeah. So first of all, what is a test? What is testing? Why do we need it? So we are going to talk about all those things, like starting from what, why, and then how we can do the testing, and what are the packages which are there in Golang, and how we can use those packages. So yeah, what is a test basically? So it's a very basic, like, repeatable steps by which one can verify if something is working as it is supposed to be. So whenever you are doing a development, there has to be some outcome, right? So there is some expectation which you have while developing your code. So to check that code, to verify that it's working as per your expectation, that's when you write a test, like, to verify that particular piece of code. So that is what a test is. So, like, if we look at our like real life examples, like, we need testing at every part of life. Like, for example, if you are going to a supermarket, you are purchasing a product, you do basic testing, right? Like, whether it's an expired product, and is the quantity is up to mark, and all those basic things. Like, so you do that testing. So it's similar to that. It's very normal, similar to that approach. So while writing, software testing is necessary. Why? Because we all make mistakes, right? Like, some of those mistakes are not important, but some of those can be very, very dangerous. So we need to address all the bugs, all the problems which can occur while we write code, we develop things. So that's why testing is very important. So there are basically four, I would say, main pillars which you can get while after writing the test cases, and after doing the end-to-end testing of developed code. What is that? That is fast. Like, at first you might be thinking, how can testing make your development process fast? But it can actually make your development process fast. Why? In the longer run, if you see, so if you are writing just a basic program, you would be like, okay, if you are writing basic search program, so you'll be like, okay, I just need to search basic any particular variable in a program. For that, you don't need to write tests. Like, first thing it comes to my mind, like, I'll have to set up the entire framework and then write the test suite. But when you develop real life applications, like large applications, you need to write tests, because further in future you might need to add more functionality to it, and you need to modify that code. So for that, there should be test cases, because accuracy also, like, you need to check whether your test is working as per your expectation or not. Like, while just developing and running the code, you can just see, okay, this is what you are there is if you have created a function called user authentication system, so you'll just test ki, okay, you are able to log in, you are able to register, and all those basic things. But sometimes there are some edge cases and edge scenarios which you are not able to predict while developing any functionality of your code, so any functionality of your system software. So it's very important to write test cases, to do testing. It also brings reliability to your code. Like as I said, if for example if you want to make changes to your code, so it should be reliable. Like what if you are making change at one place and it is affecting other part of the code, like somewhere else in other function, wherever you have used that particular function, it is affecting that portion. So that means your code is not reliable, but it has to be reliable. So for that also we need to write test cases, and obviously it should be predictable. Like as I mentioned this case, like it might affect some other areas. So that's predictability. Like with test cases you can look for you can look in the entire code base, that okay, if you change at this particular place, it is going to affect at these 10 places. So that's the predictability. So these are four things which we are going to achieve after writing test cases. Yeah. So yes, so this is very important thing which you need to keep in mind, which is tests are software too. As in, while writing test cases, we might not very as much as responsible while writing code, as in while writing the functionality, because it's like, okay, these are just test cases, but we need to have some kind of rules and regulations which we need to follow while writing test cases. So what are these? One is single responsibility principle. As as we all know, like while writing normal functionality of your software, you follow these principles. Like a class or a function should be focused, not doing unrelated tasks. Yes, like if your function is doing just the search portion, then your test case also should only be testing that search functionality, should not be testing some other parts of your software. So that this is very important feature which you need to keep in mind. So what it is saying is, note that does not always mean just a single assertion. It is fine to use multiple assertions if that is what it takes to validate that something occurred. Yes. So I'll give you an example later, which is, for example, there is linked list which we have created. So there are various functionalities which are relevant to linked list, like adding a node to a linked list, and then removing a node to a linked list, then adding in the middle, adding in the end. So these are few basic checks which we do while writing linked lists. So this can be a part of one test suite. Like it's not that one function should have only one entire test suite. It can have all the related functionality in one test suite. That is a single responsibility principle. Another is don't repeat yourself. Yeah, just like your functions. Like why do we write functions? Because there is some part of your code which you are going to use at various places. Like take any example, like if you are okay, in case of linked list, if I have one a print function, and I want to print after inserting item at the first place, at the last place, and even after deleting, so I can create just one print function and then call it at various places. Similar approach we should be following for test cases also. Like if there is one test which you need to call at multiple places, just write one function and then call it at multiple places. You don't need to write it again and again. So yeah, treat it as a software while writing test cases. Yeah. So this is a testing checklist. Like how should we proceeding with writing test? First, like write a unit test, yes, and then build and run test. Notice errors, do minimal amount of work to fix them. Yeah. because try to write better code at the first place, and then notice the test is failing. Yes, that's a red flag. And then write some code to fix that particular problem, like so that your test can get passed. So that is, yes, green flag if your test is passed. And then repeat this process for entire application. That's basic testing checklist. Now, so Golang comes with testing package in itself, which we will be using further when I'll be showing you examples. So this package provides support of automated testing of Go packages. So yeah, while, so for example, if you are writing a functionality, if you are not using test case, you will have to do manual testing, right? Like you write a functionality, you will have to check that if it's working or not, but you are doing manual test for that, which can lead to problems. As I said, we human, we all make mistakes, right? So it's better to do automated testing at the first place. So even after sometimes, if you, after maybe later, if you will be visiting that particular piece of code, you don't need to really look into the functionality or something. You can just look at the test cases and just run the test cases. If they are working fine, then that means your code is working fine. So that gives that gives a like sense of automation also, like it makes all the entire process easy. So it exposes a set of useful functions that we can use to get couple of benefits. What are these? A better looking code, yes. If there are so with Golang, as it's strictly typed, all the checks and those things, you cannot import anything if you are not using in the function. All those things are done while you are compiling your code. So that is another very great functionality with Golang. um, so yeah, better looking code, and then standardized approach to testing and nicer looking output, yes. uh, Obviously, if you are writing tests, if those are not passing, if you are trying to validate your code, so that is just making your code better and better, and eliminating the need to create our own reporting of failed and past tests, yes. Like we don't need to, like we don't need to create a checklist. Okay, if this happens, that means okay, this is passed and this is failed. It just, you just need to write the test cases and that will do your job. And okay, so this testing package comes with go test command. So what it does is it basically executes whatever test suites you have written. Your test function, your functions should be in this format. Like function, it should start with test keyword, and then for example, it's user. If you want to test user functionality, right? Like user package, if you want to test your user package, it should be test user. U should be capital U, and then user. And here we are passing testing package, reference to testing package. So as I spoke about running test suite, so there are basically two modes which we can use to run test cases. So one is local directory mode, which is where you can go inside the package and just run whatever is there in the package. Like so here, for example, in this case, I am inside this package, binary search, and I don't need to provide anything related to package. Like I don't need to provide the name, I don't need to provide the path, nothing. It's in the package, and then just do go test. It will run. It will first check for whatever test file is there in that particular package. It will look for this particular signature. Like if there is a file with test binary b capital and then binary search, so it will try to execute that particular file. This particular go test hyphen v basically gives all the details. Like if you are running go test, it won't give you like running this function and pass. It will just give you okay. Like it will just give you the logging information of failed cases, go test. But go test hyphen v will give information of failed and passed, both of the cases, all the logging information. Next type, which like next is package list mode, where you are in the directory, not inside the package, like outside of the of where packages reside, and you can just go there and write the name of the package, like go test math, go test. If you do this, like it will go inside inside all the packages, look for all the test files and run all those test files. So that's how package list mode does run test cases. Next is, yes, so while writing test cases, we need a helper package also, which is assert package. So to use assert to accomplish the objective of a test, verify that something is as you expected it to be. Like, if you look at this example here, assert dot equal, so assert library has a lot of functions which we can look here. Like, this is the package. I'll open it in another link. So we can use various functions which are provided. So here what I'm doing is like calling this particular function of the package and comparing. So this is for example, it's an object which is created in the code, and I am just checking the length. If it's equals to 3, then the like uh, length is correct, otherwise it's false. Basically it fails. So assert basically checks if it fails or passes based on some condition which you write, based on, so you are applying a condition and just checking if that condition is true, then your test case pass, else it fails. So package assert provides a set of testing tools for use with normal Go testing system. All assertion tests take testing T. So this is since here I showed like it is taking a reference to testing package. So we can use assert package only with the testing package. So it takes it as first argument, and then it write all the failings and all the details which are related to that particular function to this particular object. And then every assertion function also takes an optional string message, like here as I sent this string message, it's optional, which allow you to show some custom error messages. Like here I can clearly see, okay, there is issue related to the length of linked list. So yeah, that's what we use as a helper package. Okay, that was all the theory of writing test cases, like basic test cases. Now, yeah, there are some rules while you are going to write test cases. One is create. So first step is like you create a new test file. Like there is code you have written. So as we are going to talk about linked list, so there is, for example, you have written the entire algorithm in a package. So there is a package linked list. There is one file called linklist.go where you have written all your functionality related to linked list. Right now you want to test that particular functionality, if it's working or not as per your expectation. So first step you do is create a new test file. So what are some rules which are associated with this test suite process? That the test file name should be like this. Like if we are talking about linked list, it should be linklist_test.go, because that's what your Go test, when you will be testing your that package, it will be looking for these files. If it's in this format, then it will pick those files and run those files. So it's important to follow this process. Okay, so there are two types which you can do. Like this is basically how you can structure your test packages. One is you can write test files put test files in the same package. For example, if here I'm talking about linked list, so you can just write functionality in one file and test case in another file, and then put both of the files in the same package. Or that is like a white I would say that is white box testing, because you don't need to basically import each and everything, because you have access to everything which is there in the functionality file. But I think I feel the second approach is better, where the functionality part is in different various packages, but there is one package which is specifically for test cases. So whatever you want to test, you put all the files in that particular test package. So with this, like you basically you're hiding your implementation details, like you are not showing your implementation details also in the testing package. So that's, I think that's a better approach while writing your test files if it's a bigger project. Next, like write a test function. We just created a file, right? It's a blank file. We need to write the test function. So the function name should be prefixed with test, as I mentioned earlier. Like this is how your Go test runs. Like it will look for this function. If it's prefixed with test and then followed with name, which is first letter is capital, so that's how it will run. It's a signature. And a function that are not prefixed with this will not be treated as test cases, as I mentioned earlier. They will not be run when a go test command is issued. So that's how go test command basically works. Next is understand the test suite. Yeah, so we have written the test suite. Now let's just go deep into it. So here we have written this auth test. Right. So the auth test can contain more than one test function, not only test login. So if I have written only one function, it can contain multiple functions, as I explained earlier also. So there can be many related use cases, right? So if you are checking the authentication functionality of your application, so it can contain multiple things, which are registration process, login process, password reset process, and many other related functionalities. So similarly it depends on you. It always depends on your package. It always depends on your functionality. If functionality is bounded to each other, like functionality contains multiple things, multiple functions, you can test all those in one file. That would be called test suite for that particular functionality. So yeah, let's just look at the code first, I would say. Okay. uh, all right, let's just look at so this is basically, this is all the it's it has all the data structure functions, all the data structure functionalities. So let's just test for singly linked list first. Test, let's look at the functionality. So it's a basic singly linked list program, which is we have taken a node, we have taken a linked list, and here we are getting a new node, creating a new node, and then this is empty linked list, and we are basically validating, checking basic things, if it's empty, and then how we can initialize that empty linked list. And then here we are inserting at the beginning of the list. So this is whatever is the algorithm of the linked list. I have followed that basic approach, like inserting in the beginning, and here we are inserting in the end of the linked list, and inserting at any position, any given position, and deleting from the beginning. And here I am trying to delete from the end and from a position, and then it's basically printing that linked list. So this is the entire functionality of a linked list, a single linked list. So now we want to test this functionality. Um, to test this functionality, as I mentioned earlier, we will be using a testing package which comes with Golang, and like default testing Go automated test package. And this is assertion package, which I explained we will be using to put conditions to check if it's giving what I am expecting from that particular piece of code. So for that we are using this assert. And here, for example, if I want to test insert beginning, Right. So here I have just I have created a new node with value 2 and then 34, then 93. So how it should be, if I am inserting in the beginning, it should be like, 2 and then 2, and then I created a new node which is 34. So it should be preceded with 34. It should be 34, 2, and then 93 is there. Then it should be 93, 34, and 2. That's what we are expecting from the linked list. And here we are checking that, okay, linked list, length of the linked list should be 3. So these are basic tests. You can extend these tests based on your the entire functionality. So it also depends on your use case. So here we are just checking the length of the linked list, and we are testing if head of the linked list is not 93, then it's not working, because it should be 93, right? So that's how we are testing this particular piece. And then if you want to test at like inserted end, same approach, like you have created a node and then called the insert end function, which I have created, which I have written here. And then we are checking the length, and then we are checking if the last item of the linked list is equal to this or not. So that's how we have that's how I have written all the test cases. So let's just run this particular piece of code. Yeah, so assert, yeah, I have already explained it. Yeah, let's just test. If I test with go test, okay, I need to go to, so here I am testing with the local approach, like going into the directory, going into the package, and then testing this particular file. So let's just yeah, so I'm inside the package, and now I can just, so so to run your program, you just put the command go run, but test cases would not work with go run. So you need to specify go test. Okay, it ran successfully, but it didn't give me the entire information, like this is the output of this function, this is the output of this function. I want those details also. So let's just do um let's just run it with -v, which is going to give me details. Yes. So let's just look at all the cases. First I tested insert in the beginning. So it's 93, 34, 2, correct. And then insert at the end, 222 should be at the end, it's at the end. Yeah. And then insert at the position, which is position is 3. So at third I have 555. Yeah, correct. And then delete beginning, it has deleted 93, which is correct. Delete end, which is 222, which is correct. And then delete from position, and it has deleted 555. Final is 334, 2. It's correct. So let's just try to fail a test case. Let's just try to let's just look at how our test cases look when they fail. So let's just do something. So if I delete this piece, like I am not updating the length of the linked list, and yeah. Oh, okay, so it failed. So insertion happened successfully, like we didn't make any change to the insertion part. So inserted beginning worked, and inserted end worked, inserted position worked. So the error occurred at deleted beginning. Yes, because here we changed. And yeah, then following all the deletions gave error. Like here you can see, like expected is 4, actually is 5, and length is not correct. So similarly, like you can put a lot of cases, like this is basic testing. Like I have not written it in a very smart way, but you can write a lot of multiple cases based on your functionality. Also you can just simply run your test cases from here also. Like you can just run. So this is part of VS Code. Like if you are coding in VS Code, you can just run and debug. You can also debug your test, like from here only. And how here you can just run your test test case. So this was like testing using the uh, testing framework, testing package, which comes with Golang. Apart from this, I have uh, yeah. So yeah, so that was all the part of testing framework which comes with Golang, testing package which comes with Golang. Now let's look at what are basic methodologies which we can follow to write test cases. So there are two type of methods, which one is test driven development, another is behavior driven development. So what is test driven development? So as it name says, like test driven development, first you write a test case. So so you know what you need to build, like you need to build and any auth function, for example, or take the example of linked list. You need to create a linked list which should have the following function, which is insertion at the beginning, insertion at the end, and insertion at any position, right? So you'll just write a test case, like this is what you are expecting from your function, expecting from your functionality, and then you'll just try to run the test case. Obviously it will fail because you have not written in functionality any functionality for that particular piece, and then you will write code to pass that test, like you will write functionality, minimal required functionality for that particular test. Like you will write logic for insert at the beginning, insert at the end, and in the middle. So if that particular piece of code passes the test case, that means it is working fine, working as expectation, and you can then improve the quality of your code and change its behavior. That's what TDD is. It's always test driven development. First you write the test, and then you pass that for your code. So what it says is, you define a test for a function you haven't implemented yet. Yes, because you are writing test case first, and then write the minimal code to achieve that expected behavior. Whatever you are expecting, that is in that test suite. So that's what TDD is. But there is a different approach to testing as well, which is behavior driven development. So let's first read it. It's from Martin Fowler. The essential idea is to break down writing a scenario or test into three sections known as given, when, then style. So let me first explain what is behavior driven development. So as you know, what your how your function, how your code should behave. Like you have given a requirement, and you know how it should behave. So you write your test cases, you build your test cases around that behavior, not around your code. Like in TDD, we were building the test cases which were revolving around the test only, around the code only. Like it should pass all the checks which are related to code. But here we are building the test cases which are related to behavior of your system, behavior of your software. So next is the given part describes the state. So we have three parts, right? So given is prerequisites for the scenario. Like so if you are building an authentication system, so you know how it should behave. If a user comes in and enters his credentials, it should authenticate that particular person if he is entering the correct credentials. So that's given in the scenario. And when the action to be tested, and then the desired observable outcome. So you know what you are expecting. If that test case is passed, if the person is entering the correct credentials, it should give the desirable outcome. Whatever we are expecting, he should be logged in successfully. So that's what BDD is. It revolves around the behavior. Yeah, so this is how BDD looks like. There is this section described where like so this is from Gingo package, which is the package in Go, which gives you provision to write behavior driven test cases. So here, like this is the strings package, and the context is like if I am checking if string contains, checking the contains functionality. So I am looking if the string contains the substring in the middle, and it returns true. So here this is what I'm checking, that this is the string and this is the substring if it's in the middle. So is in the middle, so it'll be giving us the true output. So it's very like just normal language driven, as we are talking, like if someone is telling me the requirements, if a business person is telling me the requirements, that okay, this is how we want our system to be, this is how we want our system to behave. So as they are putting the requirements, that's how you are going to write the test cases. So I think bdd, so why is bdd very important? And it's evolving, and people are going more towards bdd. Why? Because bdd is a testing methodology that makes applications largely self documenting. Yeah, so as you have looked at this particular piece, so it's a very is doing, like it's checking if the that's what it's doing, like the is doing, right? So it's largely self documenting. It's able to do this because the tests are written in a way that's reflective to the plain language, like as the earlier example has explained almost everything. And then the bdd approach makes it easy for people who are not technical in nature, such as business analysts, to read and write test specifications. So it's very readable as compared to tdd, because in tdd you mostly writing in coding language kind of, but in bdd you are mostly writing in plain kind of texture. So that's more readable for other people also who are not very techy in nature. Doing so helps ensure applications do what the end user expects them to be, as end user play an active role in determining test acceptance criteria. Yeah, so end user play an active role in determining tests. Like they can look in the code, and like they can just tell, because they are telling us the behavior of the system, and we are building test cases around that behavior. So that's what bdd is. So yeah, thanks. There are some packages for bdd in golang. So I have used gingo, which is very nice. I think you can check that. And there are many other packages. So yeah, so whenever you are writing a piece of code, doing development, I think you should definitely uh, try to write test cases also, like that will save a lot of time. Maybe you won't see in the beginning, but at the end, like maybe in the future it will be very useful to have those test cases. Yeah, that's it from my side. Thank you.
Thank you, Ekta, for taking our time and giving the wonderful talk.
Thank
I
you.
think there are no such questions, and if there are any questions, then people will post you and they'll contact you directly on Twitter.
Sure.
Um, and would request you that if you can share the slides with us on the channel and we can post it over
Sure,
there.
sure. I'll
As well.
share it. Yeah.
Sure. Thanks a lot, Ekta, and thank you everyone for joining in us. And we'll see you next week. Thank you. Bye.